Hello and welcome to episode episode 5 of How to Code a Game Like Minecraft in Unity. In this episode we are going to create some basic terrain. In the last one we generated our trunks, but our trunks are fairly bland and, let's be honest, a bit boring. So in this one we're going to make them look like an actual, not a final world, obviously. I'm only going over the basics here in general, but this is just going to get the basic shape of the terrain and a bit of detail in the makeup of the terrain, which will hopefully become a bit clearer as we get going. Also, before I get started, just let's say somebody commented on one of the previous videos if I could make my code a little bit bigger because it's a bit difficult to read, just the font size, which I'm going to do, obviously. If anyone's got any pointers like that, anything to make the videos a bit easier to follow. I understand it's a bit of an uphill battle with my accent and voice in the first place, so anything I can do to make it a bit easier to follow along, please feel free to comment, let me know. And also, because it's a YouTube video, like and subscribe. Yay! So, we'll start off, we're going to use Perlin Noise, which I don't know what level everyone's at. I'm assuming most people watching my videos are fairly beginnerish, because if not, why are you watching my videos? So we're going to use Perlin Noise, which is a pseudo-random, I guess pattern you'd call it, procedure. Basically, it creates a random pattern of zeros and ones and everything in between. So I'll pull up a picture and it'll be a lot easier to explain. So this is a visualization of Perlin Noise. So if you imagine all of the black patches, all of the absolute black is zeros and all of the absolute white is ones, and then all of the grey shades in between is 0.1, 0.2, etc. What this is it's obviously fairly random, looks like a cloud at the minute, but it's repeatable. So if you start off with the same seed and then you pick a random coordinate, because you can pick any X and Y coordinate in Perlin Noise and it will give you back you'll be able to get a 0 to 1 value and anything in between. And if you have the same seed and pick the same coordinate, you will always get the same value. So it's not truly random, which is what we want doing a game like Minecraft, because the way you want the seeds to work that way, because otherwise you're never going to be able to generate the same world twice. So we're going to use Perlin Noise to do this. So to start with, we're going to create a new script. We're just going to call it Noise for now. And we'll open that, and I will make my code bigger as requested. We'll go there. Just only a bit more than one function on the screen. So this is going to be a static class like our voxel data class. We don't need to run any functions in here. We don't need to run any mono behavior functions in here. And we would like to be able to get to it from wherever. Now, Unity has a function built in, a Perlin function. We're going to use that. This is not the most performant noise function available. As far as I know, Simplex, which is one of the more common ones you'll be able to find if you do a quick search on Perlin Noise, is better. So I understand. I've not done too much research on that particular thing myself. For the purpose of this tutorial, this will be fine. If you want to replace this Perlin Noise with another Perlin Noise or your own Perlin Noise, if you get adventurous and want to code your own, it should work exactly the same. We're not coding our own Perlin Noise function, we're just using the existing one. So you can swap this out with whatever you want. So we're going to create a public static float, and we're going to call this one get 2D Perlin. And we're specifying that it's 2D because there will be a 3D Perlin later on. So we do need to distinguish between the two. So it's going to take in a vector2, it's going to take in an offset, I'll explain that in a bit, and it's going to take in a scale. And then in here, all we're going to do is return mathf, however you pronounce it, .Perlin Noise, and then we're going to pass in, first off, position.x, and we're going to add just a 0.1 here. And the reason for this is there's a bit of a weird bug in Unity's Perlin Noise where if you pass it a whole number, you will always get the same value. I'm not sure why. It's been around for a long time. I'm not sure why it's not being fixed. But if you pass in, there should be a dot here, by the way, sorry. If you pass in a whole number, it will always give you the same value. I think it's something like 0.475, whatever it is. So that's all this 0.1 is just to make whatever we pass in not a whole number, because we are only dealing in whole numbers in this game. It's always 1, 2, 3, 4, 0, whatever. And then we need what is kind of a tile size. We're just going to use chunk width, because why not? And then we want to times that by our scale, which is spelt like that and not however the hell I just typed it. And then we want to plus our offset. And then if we just copy this for our Y value, but obviously we want to change this to position.y. Close the brackets. And that is all our 2D noise function is going to do. Because the Perlin Noise is Perlin Noise. This scale, so basically when we take a sample of our Perlin Noise, the scale will determine how big it is. So with a smaller scale would be like this. So a sample might be over here or over here, whereas passing in the same value with a smaller scale number, it will be like over here or over here. So essentially by adjusting the scale, you can make... The easiest way to explain it is if you picture these white parts as mountains and the black parts as ground. That is one of the most common uses for Perlin Noise. You'd have a more bumpy, mountainous ground, and then if you reduce the scale, which is ironically makes the Perlin Noise bigger, then you would get less mountains, but sort of a more rolling hill kind of thing. Hopefully it'll become clear as I get into it a bit more. So now we've got that, we're going to need to open our world script. The first thing we're going to need to do, we'll give ourselves a public int seed. And where that's going to come in is at the very start, we need to initialize the random state machine. And this means that as long as this number is the same, we will always get the same Perlin Noise. So as long as this number is the same, the world will always look the same. So this is if you've played Minecraft, and I'm assuming if you're watching this tutorial you have, the part where you have the option to write in anything you want. We can only put an int in, but you can... That's something that's not too difficult to change. This is that value. And then if we go into Unity itself, we'll just put any once it's caught up, we'll just put any random number in. There we go. Now to show the to show it actually working, just so you can see it in action, we're going to go down to our get voxel. And so basically we've got right here, this is returning bedrock, this is returning air if it's outside, this is returning bedrock if it's the very bottom, this is returning stone, and then this one is the one that we're going to mess with. This is, if it is the very top block of a chunk, it's returning grass. So we're going to change this. Just get some curly brackets in here. And then what we're going to do is we're going to get a float. What should we call it? Temp noise, I guess. It's not really important. And this will equal noise.get 2D Perlin. The position is a new vector2 pos.x pos.z. We don't need the y value, obviously. The offset is entirely unimportant at this point, so we'll just put no, and the scale we will just put 0, 1 for now. Now with that float, we're going to do this. If, because remember these values, the value it's returning is a normalized value between 0 and 1. So if temp noise is less than 0.5, return 3. And then else return... Oh, you know what? We don't actually have a I need an alternative block, and I don't think we've got one. Yeah, we're already using stone and grass. We need another block, otherwise we're not going to know that it's working. So if I just pull up wherever I put it, my texture reference picture, we'll use sand. So 10. I'll call this one sand. All the faces are the same, and it is solid. And that is now index 0, 1, 2, 3, 4. So go back in here. So if it's below 0.5, return 3. If it's above, return 4. So now we should have a bit of a pattern on the top of our chunks. It's not much of a pattern, but if we move around we should see more of it. So it's something. Like this is really just to show you it in action. So it's essentially what's happening here is because we're only sampling below and above 0.5, we don't get all this detail. We're just getting 2 different colors. So it's reducing all this detail to this pattern. And that's what we need. So now that we have that in place, we can make things a little bit more interesting. So the first thing that we want to do is we want to go in back into our get voxel, and we're going to start reworking this entirely. So in fact, let's just get rid of everything except for that we're keeping. So we're going to break it into sections. So this top section, we'll just call this immutable pass. And what this means is that anything that's done here is absolute. So this first check that we've got here, if it's outside the world, that's what that check does, then we are returning an air block. That's always going to be the case. It doesn't matter whereabouts in the world we are. Well, we're outside the world if that one's checking true. But anything that's in this immutable pass bit, it doesn't matter where we are in the world, it doesn't matter what biome we are, it doesn't matter what height we are, it doesn't matter what seed we're using. These values will always return exactly as they are if this condition is true. And the same for, you know what, let's just give ourselves a little bit of a value up here because we're going to need it. It'll just be a bit easier if we just make this an int from the start. And I'll start annotating these a bit just to make it easier to follow along. Right, so for now they're the only immutable values we've got, but basically if it's the bottom block or it's outside the world, it will always return these values. None of the other information is important because the bottom block is always going to be bedrock. The outside the world is always going to be air. Or you could make this a solid block. It's not going to draw the block. Remember, this is just so that we know what to do when we get to the edge of the world. Returning it as an air block means that it will always draw the outside of the world. So you get like a solid chunk edge around the outside of the world, which we're going to leave like that, so that you can see some of the detail later on once we've got going with the actual terrain generation. So if we get past here, then we're into our next pass. We're going to call this one we'll call it basic terrain pass. So if we get this far, we're going to need another value, and this value is going to be called terrain height. So this is going to be, as the name suggests, the height of the terrain at this point. And to get this, we need to do a long, hard to follow line of code. So, you know what, I'll do it in this order so it's a bit easier to follow. So we're going to use our noise function, noise.get to, okay, it's already filled it in for me. New vector2 pos.x pos.z. Remember, even though it's asking for a y value, y is height, and we're only dealing in 2 dimensions at the minute, and our 2 dimensions in the real world are x and z. So it's important to try not to get confused by y and z when you're dealing 2 and 3 dimensions at the same time. We're just going to put 0.25. I've played with these values a bit, so I'm not entirely unsure what I'm doing. Right, so right now that's just getting a... oh, sorry, I forgot my offset. No, that is the offset. Let's put 500. It really doesn't matter. And we'll just correct the spelling. That's about half of these videos are just me correcting typos. So the problem with this is we're asking for an int, obviously. This is only receiving a value between 0 and 1. Now, obviously, floor to int is either going to give us 0 like 99 times out of 100 and maybe the occasional 1. But our terrain isn't that. Our terrain's a bit bigger than that. So what we do, that because this is giving us a value between 0 and 1, we can times our chunk height by it. And then what that will do, voxel data.chunk height times that. And then what that'll do is basically this will act as a percentage. So voxel data.chunk height, which I can't remember what it currently is. I think it's like 15. Yeah, 15. So if that was 10, for example, and this returned a value of 0.5, then the height would be 5. So this translates our 0 to 1 value into a real world height based on whatever our chunk height is. And the beauty of this is you can change your chunk height at any point and don't need to do anything with this code. It will still work. So then we're going to do a check. If ypos is less than or equal to terrain height, we will return 2 stone, else return 0. So if it's less than whatever this height is, we're going to get a solid block, and if not, we'll get a if it's higher than it, we'll get an air block. And this should give us some detail now. Aha. So if we're going to chunk, because we haven't had to do this yet, we aren't actually checking to see if a block is solid before we draw it. So here, sorry. Yeah, because we've just been filling the chunk up completely. Every block has been solid. So it's not been important to check whether a block is solid before we draw it, because we know the block is solid. So we just need to put a little check here. There, so we're only drawing a voxel if it is solid, and that should get rid of that weird layer on the top. That looks better. So now we've got some terrain to look at. Well, not much to look at, but we'll just let's just change this a little bit. If ypos is equal to terrain height, return 3. Else if ypos is greater than terrain height, return air, and then finally else return to. Should make it a little bit more interesting. There we go. So we've got some basic looking terrain now, which is a lot nicer to look at than what we were looking at before. So you may have guessed from the fact that we can see bedrock on the surface that we're not quite done yet. So the problem the reason we can see bedrock is that our math here, our timesing the chunk height by whatever value we get, that is the entire chunk height. So a value, if the value comes back as 0, if the height comes back as 0, then we're going right down to bedrock. And obviously there's no terrain in Minecraft that goes completely down to bedrock. Well, I guess maybe you could have a canyon, but that's down the line. That's advanced stuff. We're just doing the basic terrain for now. So we need to deal with that. I mean, the first thing we're going to do is we're going to change some values in here. We're going to make the chunk. We're going to make the chunk height 128, and we're going to make the chunk width 16, which I believe is the original Minecraft values. And then just so we can see things a little better, we're going to make because this is going to start to get a bit more system intensive, and I don't want you sat waiting for the game to load every time I press play. So we're going to change this to 10. No, we're going to change this to 5. No, we're not. We're going to no, we're going to leave it on 10, and we're going to leave that on 5. Which, if I run it now, won't be a massive amount different. There'll just be more of everything. There we go. And now, because I've changed the world size to be within the view distance, because if you remember, the view distance was 5, but it's 5 each way. You can now see the edges of the world, and obviously the edges of the world are solid stone. It's starting to look a bit more like Minecraft. Not much, but we're getting there. So what we need to do now is we need to give it some more detail. And the way we're going to go about that is we're going to create a scriptable object first, because we want to be able to, in future, we want to be able to have multiple values for generating the world. And we don't want to have to change all that in code. So we'll call this biome attributes. And this is going to be a scriptable object, so again, it doesn't need any of the monobehavior stuff. Scriptable object, and we're going to want to create stuff, create these from the asset menu. So create asset menu, file name equals, and obviously these names are whatever you want to call them. This is just what I'm calling them. So if we go back here, we're going to create a folder for it. We'll just call this data, and then in data we'll create another folder for biomes. And then in here we should be able to create a biome attribute. I'm just going to call this one default for now. So what do we want in here? Well, the most obvious one is a string for the name, which pretty self-explanatory. Now this would be set if I was making a proper game. This would be set up. Eventually, it would be set up more complicated with more knobs and dials to twiddle. But because we're just going through this tutorial, I just want to get things done. Which is so this isn't the way I would do it if I was making this into a proper game. This is the way I'm choosing to do it to illustrate how to do it. So the first value we're going to have is a public int, and we're going to call this one solid ground height. And what this is below this value, we're going to assume it's always solid ground to start with. We may modify that after the fact, like, because if you remember, we have different passes. This is just a basic terrain pass. Eventually there will be more passes. You might want to have a cave pass, for example, or a canyon pass, or a mountain pass, or whatever. This is just basic terrain, and in the basic terrain pass, wherever we're done with that, we're going to have a solid ground height, and below this value, it will always be solid to start with. And it takes some of the burden off the algorithm, because we know if it's below that value, we don't need to do anything with it. We can just assume it's solid and make it stone or whatever our default block is. And then above that, we're going to have a public int. We'll call this one terrain height. And what this is this is the height of the terrain from the solid ground height to the highest point that you want your terrain to go. So if the solid ground is, let's say 40, and your terrain height is 30, then the highest point that the world will be, like the highest point of terrain that you will have in your world, will be 70. Hopefully that made sense. And then we're going to need a float for the scale, terrain scale. That's just going to be passed straight into our noise function. And I think that will do for now. And if we go back into here, we can set these values. Default. Solid ground height, we're using 42. We'll just make that 42. We'll make that 42. And we'll keep that at 0.25. In our world class, we need to take in that data class. So we just drag this into here. Now we can use it in our world class, in our get voxel function, which I have lost. There we go. Right, so this pretty much stays untouched. We still know that if it's below that position, then we need to return 1. If it's below that position, we need to return 0. None of that changes. This bit slightly changed because we now have a terrain scale. The offset, no, that's not where the terrain scale goes. The offset, we're just going to have 0. It's really not important for this one. The reason you want the reason we have an offset at all is because if you use the function, the noise function, for more than one thing, and you've got the same values in the same area, say for example you were using it for tree placement, and you wanted to use the noise value twice, once for tree placement and once for flower placement, for example, and you use the same position X, same position Z, and you had the same scale, and then you had no offset, then it would be trying to put trees and flowers in the same place every time. Whereas if you have an offset, you could use all the same details, but you would get a different result because it's essentially sampling a different part. Essentially sampling a different part of the noise. So like one might be a square over here, there, and another one might be over there, just because of your offset. Again, I hope this is coming across clear. Now we're using our biome attributes class to get some details. We can go on with the rest of it. This, we're going to leave the same, but we're going to add another one in here. Oh, we're going to need another block. A dirt block, which is 1 on the texture map currently. So we add another one of these. Dirt, obviously it's solid, and then just 1s across the board, because a dirt block is the same on all sides. And then this is going to return 1. And then you'll see what this does in a second. So all this is going to do is just give us a bit more depth to the surface layer. So we've got grass on top, we have stone across the board, and then Oh, it also helps if you pass the right value. The texture value was 1, but the block ID is 5. Always good to remember the difference between a texture value and a block ID. So now it just gives us a little bit more depth to it. Now, as you can see, it's still going all the way to the floor, which we do not want. We want to have some. We don't want it to go. We don't want our 0 to 1, 0 and 1s from the not Perlin Noise to apply all the way from bedrock to sky. So we need to implement that next. So first thing we do is change chunk height to biome.terrain height. So now it works the same way, but now it's only applying itself to this value rather than the full chunk height like it was. And then all we need to do is add whatever this value is to biome.solid ground height. And then we have our total terrain height from ground to wherever the world comes to, wherever the terrain comes to on that point. So if we press play now, we should have a more reasonable looking terrain. Yeah, that looks far more, far less extreme, should I say. And we have our bedrock at the bottom there. And we have a few layers of dirt below our grass. And we're not seeing stone through the extremely steep hills anymore. So we're starting to get something that looks a bit more Minecrafty now. But we don't want to stop there. So we need to add a 3D noise function now. So we're going to go into our noise class and we're just going to add this as as another function. This one is going to be a bool, and the reason for this is we're using the 2D noise to create depth like a height map, but we can't use 3D noise like that because it's 3D. So this is going to be a bool instead, and basically we're going to pass in a threshold. And what it's going to do is it's going to check whatever value it gets from the details we give it against that threshold. And if it's above it, then we will return true. And if it's not above it, we'll return false. Because all this is doing, all we're using this for really is to check against the noise and decide whether there's going to be a block there or not. It's kind of working like that is solid or not in the chunk functions. And we're just going to use it to basically add a bit more detail to the chunk itself. This time we're going to need to take in a vector 3. We want our offset again. We want our scale again. And this time we also need a threshold. I mean, we don't need the threshold, but we could have a static threshold, but it just gives us a little bit more control over what we're going to get back. Again, there are external things you could use to get your 3D Perlin noise. What I ended up settling on was, again, not the most efficient way of doing it, but very simple to understand. Basically, I found a video on YouTube of a guy who just had a very simple 3D noise. I'll post a link in the show notes. I'll just quickly show you it. It's this video here, somewhere along here. There we go. This basically takes a cross section of 3 different Perlin noises using the value that you the XYZ values you pass in, and then it returns 3D Perlin noise using those. It's very simple, it's elegant, it's perfect for this tutorial because you don't need to understand anything new. Once you've got your head around 2D Perlin noise, then the 3D Perlin noise makes perfect sense. So we're going to, again, full credit to that guy. I'll just copy his link in there. So we want position.x plus offset, and then for the same reason plus 0.1, because if you don't give the offset a decimal value, we're still going to end up with a whole number. And then times scale. Then we want to do the exact same thing for Y and Z. And then we need to start comparing all the values. mathf.Perlin Noise XY, and we're just going to copy this and adjust values as necessary. We need 6 of those. So this one, BC, this one AC, and then we're basically doing the same thing again, but we're reversing the values we had the first time. So that one should be Y, that one is XZ, and then again we're just reversing the values that we had the first time. Sorry, I know it's not very interesting watching me mess around with single characters on multiple lines of code. Hopefully you follow what I'm doing though. And then we get to our check. So if AB plus BC plus AC plus BA plus CB plus CA divided by 6 is greater than whatever threshold we pass in, return true. And if it's not, return false. And that is our get3D Perlin function. So now we're going to go into our scriptable class, and we're going to create a new class, and we're going to call this one loads, basically, as in like mother load, ors, that kind of thing, because that's essentially what this would be used for. It's not going to be what I'm demonstrating in this video, but essentially this would be used for generating ors in your world. So it's going to want to be a system serializable class, because we're going to be editing it in our biome attribute asset. We'll give it a string so that we can name it. Public byte block ID, and this is whatever block this load represents. So if we had an iron ore or a diamond ore block, this is where you will put the ID for that. We're going to give it a public int min height, a public int max height, and if it wasn't obvious, basically this just means that below this height we're not going to apply the this particular load, and above that height we're not going to apply it. So an example of this was, I don't know if it's still the case, it's been a long time since I've actually played Minecraft, but it used to be the case that diamonds could only be found in like levels 3 to 10 or something. So if that was the case, then min height would be 3, max height would be 10, and then you wouldn't find whatever this load is anywhere outside of that. We're going to give it a float for scale, a float for threshold, and a float for noise offset. So now if we go into here, we should have, oh no, wait, you have to actually put it in here though. Public load array loads. And now if we go in here, when it updates, we should find ourselves a nice little array we can edit. We'll give it 2 to start with. Dirt, again, like I said, I'm not working with actual loads here. Dirt was 5. Min height for this one, we're going to get 1. Max height, we're just going to put 255. Obviously the chunks don't go as high as 255, but it just means that there is no upper limit in the world for where a dirt load can go. Scale 0.1. Threshold 0.5. Offset we will leave at 0. And then this one, sand. Block ID for that was... I can't remember. Block ID for sand. Oh, right, okay. 4. 4. And this one we will give a min height. So we'll go 15. No, actually, let's go a bit higher. We'll go... Let's go 30. Max height... Oh, 255. So basically, this means that we... Well, let's make it a bit higher, actually. This means that we shouldn't see any sand below... Now, I'm a bit worried that we're not going to generate any visible. Let's go 30 to 60. So there's a 30 block patch where sand can be generated. We'll give this one slightly bigger scale. So remember the way this works, the bigger the scale, the smaller the sample size that we'll end up with. So this should mean that we have bigger lumps of dirt and smaller lumps of sand. And we're going to give the threshold 0.6. And this one we are going to give an offset where just to make sure it's completely different to the dirt, we'll call it 500. Again, it's not really important. So now if we go into our get voxel and we want to apply this. So the way we're going to go about this is we're going to, instead of these again stay the same. So if we hit these, we're going to return that value because we know we're not doing anything else with them. These we're going to change, and we're going to have a voxel value equals 0. And instead of returning straight away, we're just going to set the voxel value to that. Except for this one. If it's in the air, we're still just returning 0. And then this one, voxel value equals 2. And the reason we're doing this is because we don't want to return the value straight away, because if it is one of these values, we might still want to do something with it. As it turns out, the way we're going to do it at the minute, it's only going to be if it's 2 that we're going to do anything with it, but that can change. So we're going to move on to our second pass. And this is where we add a bit more detail to it. So the first thing we want to do is we want to check if voxel value is equal to 2, then we're going to do our stuff. If it's not, we're just going to, for now, we're just going to return voxel value. For the time being, we're only going to be messing around if it is stone. If it's the grass or the dirt layer, we're going to leave it alone. Again, this is all going to be entirely up to you how you want to generate your world. I'm just trying to show you enough information for you to figure out how to do that. So then we're going to loop through each of our loads. Oh yeah, sorry. This voxel value is a byte, not an int. And then, so for each one of our loads, we're going to do a check if ypos is greater than load.minHeight and ypos is less than load.maxHeight. So if it's within that range between the min height and the max height, then we do another check. If noise.get3d pass in our position, we don't need to set a new one now, we can just pass in the position wholesale. Load.noise offset, load.scale, load.threshold. If that's true, return, oh no, sorry, voxel value equals load.block ID. So what that should do is give us an error where we're not returning a path. Oh right, yeah, sorry, this doesn't need to be an else because we're returning voxel value regardless, so that didn't need to be an else. So now, if we run it, we should get a little bit more detail. There we go. Obviously, it's not exactly it's not exactly stunning right now, but you get the idea. So you can mess around with these values, mess around with the ranges and the limitations or whatever, and change the block ID, and you could be generating loads, or you could change it to, instead of giving it a block ID, you could just give it the air block and create caves. So we've got all the groundwork for some pretty basic terrain generation. There is one thing I wanted to just quickly look at. If I just drag this over here, I believe there's a bit of a problem with the camera. Well, not the camera. Basically, we're using unlit textures, and it's not as obvious as it was now. But if you see these little lines there. Between the where the seams are on the mesh, basically. It's a bit more obvious down here. Basically, that's a bit of a bug. If we go into project settings, go into quality, and 1 second, I'll do this when it's not running. And if we turn off, what was it now? Anisotropic, sorry. Disable that. And disable anti-aliasing, that should fix that weird little problem. It's something to do with using, I think it's just a bug, to be honest. But now that it's off, we should have a more seamless, yeah, we're not getting those weird lines anymore. And the world's disappearing there because I'm going off the edge of the world. If I increase the world size a bit, I don't want to increase it too big because again it's going to bog the system down. But if I increase it, well, we've still got a view. I'll keep the view distance small because this is very unoptimized, so this will slow down very quickly. But if I increase the world size while keeping the view distance small, you should be able to see the world generation in action a little bit better. So we'll just go up here. Now this is what I mean by it being very unoptimized. Obviously, when you're playing the game, you don't want it to be having this massive lag spike every time you generate a new chunk. I'm going to partially address that. I don't want to get too deep into it because then you start to get into things like threading, and if you're into looking at things like threading, you're kind of getting beyond the scope of my tutorials. Like, once you're getting into things like threading, you kind of want to be watching somebody who's a bit more advanced than I am. Like, I want to be watching tutorials about threading, not teaching you guys how to do it. But I am going to do some things that are going to make this a bit more performant, a bit less laggy on the system. But that is pretty much it, I think. Hopefully it wasn't quite as painful as the last video. A bit shorter, a bit less coughing and spluttering. And we've got something that looks a lot more like Minecraft at the end of it. In the next video, we're going to have a basic character controller, so we can start walking around our very basic and bland and boring world. But for now, that's everything. Again, if you like the video, please feel free to like and subscribe, because that's what YouTubers are supposed to say. We'll see you next time. Bye.